Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS exam only. We have been covering the topic, the third paper of statistics, which is of descriptive type, and we have covered the topic econometrics. And now we have started with a new topic, sampling, in which we have completed simple random sampling with replacement and simple random sampling without replacement. Today we will move forward to simple stratified random sampling. Today's topic is stratified random sampling. It is the second kind of probability sampling that we discussed in the earlier classes. So let us begin. Stratified sampling. Now, if we think about simple random sampling, or we go back to simple random sampling with replacement or without replacement, we have a whole population and we just pick one individual or one sample unit, then second sample unit and third, irrespective of how they are represented, or we can say they are equally. If we take an example of men and women, let us suppose there is a population depicting men and women, and we have to this is the whole population, and we have to sample it out with respect to simple random sampling. First sample, sample 1, can be one man. We have to take out suppose three samples out of it. This can be three men, and this can be two men, this can be one man, and this can be zero men. And for women it can be zero women, one woman, two women, and three women. This is sample one, two, three, four. Now we see in simple random sampling the ratio of men is to women changes. It can be 3 is to 0, 2 is to 1 is to 2, or 0 is to 3, whatever. It changes at every sample, even in simple random sampling with replacement or simple random sampling without replacement, it is changing. But if we and there is also not equal representation of every unit. If we are talking about men and women, these are two groups, so in the population, so there is not equal representation of men and women. Sometimes men is greater, sometimes women is greater, and so therefore the comes one more technique of sampling, which is known as stratified sampling. In stratified sampling, we divide the population into two homogeneous subgroups or strata. Stratas are nothing but groups, which are, or we can say, homogeneous groups. Homogeneous means having same characteristics. Each group have same characteristics within itself, and two different groups have different characteristics among between them. So all men are considered as one group, and all women are considered as another group. So now, if we take sample from here, stratified sample, we will take one man from here and one woman from here. So our sample in stratified sampling would be sample number 1. If we consider, It will and sample number 2 and 3. Let us consider 3 samples. So in sample number 1, one man, one man, one man, as we are allowed to only select one man. Either this one man in sample 1 can be this, in second one can be this, in third one it can be this. And for women, for the second group, one woman, and one woman. It can be either this one, or this one, based on the sample. So this is the basic structure of stratified random sampling. There is one more example as what is stratified random sampling is. So if we have to consider what are the savings of citizens of a city. Suppose we have to find out this. We have been given a population. Now the population consists of so many people. So we will divide it into 4 strata. Suppose 20 is people who are between 20 to 30. Then 30 is people aged between 30 to 40. 40 is people, and 50s or above. So we have divided our population into 4 strata or 4 groups. Now we will take equal representation of every group so that our population is equally represented and hence is homogeneous within the groups and heterogeneous among between the groups. So this is the basic structure of stratified random sampling. Now comes what are the notations of stratified random sampling. Let us suppose Yij is equals to jth unit of ith stratum in the population. Before this, let us draw a structure of stratified random sampling. So we have a population of size capital M, and now this population can be divided into various stratums. Suppose N1, N2 up till Nk. And from these stratum, we will do simple random sampling without replacement and find sample 1. Same simple random sampling without replacement, we will find sample number 2. Then simple random sampling without replacement, nth sample, nk. These are the strata and these are the sample. And we also known as summation of I goes from 1 to k. Ni is nothing but capital N, and summation I goes from 1 to k. Small ni is nothing but small n. This is the basic structure, or we can say the diagrammatic form of stratified random sampling. Now moving on to rotation. So Yij is considered as yth unit of ith stratum in the population. And small Yij is nothing but jth unit of ith stratum in the sample. Now ith sample ith stratum mean y bar I is the ith stratum mean, which is nothing but 1 upon capital Ni summation I goes from 1 to k yij for all I goes from 1 to k. Second is mean of ith sample, which is nothing but 1 upon small ni summation I goes from 1 to k yij. Again for all I goes from 1 to k. These notations are very important for the exam purpose because we have to first tell the examiner what are we talking about. We cannot directly write yij and consider that he knows everything. We should mention what we are talking, what every notation or what every symbol means. We should give this first. Then third one is variance of ith stratum, which is nothing but 1 upon capital Ni minus 1 summation I goes from 1 to k yij minus y bar I whole square, and variance of ith ith sample, which is nothing but 1 upon small ni minus 1 summation I goes from 1 to k yij minus y bar I whole square, or for all I goes from 1 to k. Now here we will find population mean. Population mean is nothing but y bar, which can be written as n1 into y1 bar plus n2 into y2 bar up till nk into yk bar upon n1 plus n2 plus up till nk. Now these can be written in summation forms. Summation I goes from 1 to k ni y bar I upon summation I goes from 1 to k ni, and summation I goes from 1 to k is nothing but capital N. So substituting that here, we are left with summation I goes from 1 to k ni y bar I upon capital N. Now this ni and capital N can together be taken as wi, let us suppose. So we are left with summation I goes from 1 to k wi y bar I, where wi is nothing but ni upon n. So this is the formula for population mean in stratified random sampling. Now what is sample mean? Sample mean is small y bar, which is nothing but small n1 y1 bar, small n2 y2 bar up till small nk yk bar upon n1 plus n2 up till nk. Now we can again write it in summation form. Summation I goes from 1 to k ni yi bar upon summation I goes from 1 to k n. Now summation I goes from 1 to k, n is nothing but small n, so we can write it as summation I goes from 1 to k ni yi bar upon small n, and this is nothing but y bar. So this is your sample mean. This completes your notations of stratified random sampling. Now we will start estimating whether this sample mean is unbiased estimated or not. If it is, then we'll move forward to variance. If it is not, then how will we find the unbiased estimator of population mean? So moving forward, unbiased estimator of population mean. So we will see whether this y bar sample mean is an unbiased estimator or not. So estimation of y bar 1 upon n summation I goes from 1 to k n I yi bar, which is nothing but 1 upon n summation I goes from 1 to k ni estimation of yi bar. Now estimation of yi bar in simple random sampling from simple random sampling without replacement is nothing but capital Y bar. So 1 upon n summation I goes from 1 to n ni capital Y bar I, which is not equal to population mean, and hence we can say this sample mean is not an unbiased estimator of population mean. Now it is not an unbiased estimator of population mean. So what to be done? We will take another mean, sample mean, or we can say stratified mean. Let us consider a stratum mean. Strata is plural form of stratum. Stratum is one and strata is plural. So let us consider y bar st as 1 upon capital N summation I goes from 1 to k n I y bar I. Let us consider this as stratified mean or stratum mean. So if we take estimation of this, estimation of y bar st, which comes out to be estimation of 1 upon capital N summation I goes from 1 to k n I y bar I, which is nothing but 1 upon capital N summation I goes from 1 to k capital Ni estimation of y bar I. This comes out to be 1 upon capital N summation I goes from 1 to k Ni into estimation of small y bar I from simple random sampling without replacement is capital Y bar I. And this is nothing but our population mean. Here we can see this is our population mean, Ni upon capital Y bar I. And hence we can say that our stratum mean is an unbiased estimator of population mean, right? And we can also write this as summation I goes from 1 to k wi y bar I, where wi is nothing but capital Ni upon capital N, right? Now we will find variance. So variance of stratum mean. So variance of y bar st is nothing but variance of, we can write summation I goes from 1 to k wi y bar I, and in variance we can take the constant term outside, so it will be I goes from 1 to k wi square variance of y bar I, right? So variance of y bar I from simple random sampling, in simple random sampling without replacement, variance of y bar I is nothing but 1 upon small ni minus 1 upon capital Ni into capital Si square. This was the variance in simple random sampling without replacement. So replacing this, we will get summation I goes from 1 to k wi square. Variance of this is nothing but 1 upon small ni minus 1 upon capital Ni capital Si square. This is the variance of y bar st, right? Now moving on further to what is the unbiased estimation of the variance. So if we calculate estimation of variance of y bar st cap is nothing but estimation of summation I goes from 1 to k wi square 1 upon ni minus 1 upon capital Ni Si square. This will be small si square. And if we'll take estimation inside, we are left with 1 I goes from 1 to k wi square 1 upon ni minus 1 upon capital Ni estimation of small si square. Now estimation of small si square is nothing but capital Si square. So we can write it here as capital Si square. Hence we can say that variance of y bar st is an unbiased estimator of variance of y bar st. This variance of y bar st is an unbiased estimator of variance of y bar st. So this is it for today, and I hope that you have understood the concept of stratified random sampling and whatever we have done in class. If not, then you can ask your doubts on the WhatsApp channel or in the comment section. So as we all know that today the result came of ISS 2025 and 35 students have been selected. I congratulate each and every one of them for their hard work and for their perseverance, and I congratulate them from Startup Academy and our whole team. Congratulate them, and all those who have made it up to the interview and still wasn't in the list, don't get depressed or don't get sad. You will keep on if you'll keep on doing the hard work, you'll be selected the next time. Keep on doing the work, and one day the selection is not far away.